Okay, so today's first topic is how to find the volume of a cone. Remember these? Great to eat ice cream in. But my first question is, if you had to eat ice cream out of an ice cream cone or a cylinder, what would you pick? Okay, I know what I would pick. I would pick the cylinder because it's got more volume. Like this would give me more ice cream than this, so I'm gonna pick the one with the bigger ice cream. You might like it out of the cone. You can eat the cone, whatever, that's fine. Here's the point. Here's the thing that we need to be thinking about. We know how to find the volume of a cylinder, of this item right here. Okay, we've done that, you've done that. Hopefully we're pretty good on that. If you had to find the volume of this item right here, we'll talk about that in a minute.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Now the Texas pledge. Honor the Texas flag. I pledge allegiance to thee, Texas, one state, under God, one and indivisible. Now for a moment of silence. Thank you.
You're welcome. So back to the topic. If we were going to compare the volume of these two items, one way we could start to think about it is just by saying, well, how many cones of volume would fit inside a cylinder of volume? And I don't know if you can tell right there, you may just have to trust me. These have the same size base. They both have a circle at the bottom and they have the exact same radius, exact same diameter. They fit together. So we're talking about two objects, a cone and a cylinder, that have the same size base. Based on that truth, how many volumes of a cone would fit into the cylinder? Maybe you can think of it like if it was water. Like if I filled this with water and I poured it in there, then how many fill-ups would it take to fill up the cylinder? And to answer that question, I'm going to flip over here to a real quick video and let you find out the answer to that. One.
Two. Three.
Wow, that's so cool. It took 3 cones to fill up one cylinder. Here's why that's important. Because it means if we found the volume of a cylinder and then we were trying to find a cone with the same base, then we'd end up with 3 cones worth into one cylinder, which would lead us to this truth. All right, here's the truth. That if you're trying to find the volume of a cone, it's going to be the same formula as the cylinder times 1/3. See what we did there? 1/3 of the area of the base times the height. Reminders, things you should know. B does not mean base. It means area of the base. And in each situation where you have the area of the base, you need to look at what the base is. The base is a circle. And so to find the area of this particular base, we're going to use pi r squared because that's how you find the area of a circle. When we substitute numbers in, we're going to look up here. We have a radius, 2. We have a height, 8. When we substitute the numbers in, then it will look like this. And I'm going to mark some stuff up just so we can see the correlations. This area right here turned into this, the pi r squared, and that's b, and that's b. Like all of those are representing the same thing. That's the b, which is the pi r squared. And then the height is obviously the h, and it is 8 high. And then we have this 1/3 here. So here's the deal. When you're running this stuff on your calculator, there's 2 ways you can do it. If you're using one of the good ones we have in class, you can make your fraction like we've done before, alpha y equals that top left button, enter, and then you type in your 1/3. And then you can do all the other stuff. It was pi r squared times the height. So I'm going to make a pi, and then times the radius, which was 2, so times 2 squared, times the height, which was 8, and that gives me an answer. And that's the right answer. But you could also do this, and some of y'all have already, you're kind of already thinking this way because you understand that the fraction 1/3, if you're multiplying times 1/3, that's the same action as if you're dividing by 3. So you could put it like this. pi times 2 squared times 8. And see, all of that is the same what we did before. That's the pi r squared times the height. And then you could just type divided by 3. So if you have a calculator at home that can make you a fraction, go for it. You want to use it, use it. If you don't have one that can make you a fraction, then just do your multiply and then the end divide by 3 and you'll be fine. Here's the way a sample problem might look. Now I might say, well, I've got a cone, has a radius of 4 and a height of 7. And I have my formula from the formula chart and also obviously from the screen. Formula, substitute phase, I take every number I can and plug it in. So 1/3 is still 1/3. The area of the base, I'm going to put in parentheses so I can kind of set it off and make sure we know where it came from. So that's going to be pi times 4 squared. Okay, and then the h, so all that just came right down here. That's the area of the base. And the height over here is going to be 7. And when you multiply all that out, I think it's around 117.2. That's coming to my mind from earlier today. But if that's wrong, well, no, I better not do that. I better actually go check it. So let's do 4 squared times pi times 7. And then I'm going to do the divided by 3 method. Yeah, 117.2, 117.3 if we rounded it more correctly.
Wait, but Mr. Campbell, I have a question.
Yes, you have a
Can
question.
you go back to the calculator?
Right there.
So I thought it was 1/3 times pi times the radius squared times the height. But you have 4 squared times pi times 7 divided by 3.
So you would kind of like it better if maybe it looked like this.
Oh.
Or you might like it even better if it looked like this. 1/3 of pi times the radius squared times the height. And the truth is, all of those will give us the same answer. Because when you're multiplying, if you keep things in a line, you're good.
Got it. Thank
Okay. And, I usually don't do this, but Ms. Walton, because as a student you asked such a good question, I'm just going to turn the class over to you and let you teach our next topic.
All right. We'll see if my questions lead to good teaching. All right. So our next shape that we're going to be looking at is a sphere. So when you think of a sphere, you might automatically go to like a soccer ball, a basketball, baseball, something along those lines in the realm of sports. And that you would be correct. So when we look at the volume of spheres, we're still trying to figure out how much space this shape takes up. But we get a new formula. And the good thing about this formula, it's a little bit complicated looking when you look at it right here. V equals 4/3 pi r to the 3rd power. So it looks really complicated, but good thing is you don't have to memorize this, even though after a couple of days you might memorize it. It will be available to you on your formula chart, and because we have access to calculators, it will make using fractions a lot easier. So as we take our formula, we notice that in our other volume formulas, we had a capital letter, by capital letter B, which stood for the area of the base. But we notice here, this formula is very straightforward. We just have 4/3 times pi times radius. The only thing that is different, or one thing I guess that is different, is that rather than a squared, we have this exponent that I just blocked out, which is a 3. There we go. A 3. So rather than it being squared, we have something called it being cubed. So our substitution with this given information, a radius of 3.2, if we substitute this, we would substitute it and say 4/3 times pi times 3.2 to the 3rd power. So in your calculator.
Ms. Walton?
Yes.
What about the height though? Like where's the height
So
for a sphere?
For the height for a sphere?
Uh-huh. Like there's no H up there.
Well, Mr. Campbell, the radius takes into account the information that we need. We don't need the height for a sphere.
So we don't have to use a height.
We don't.
The only thing we need is the radius.
The only unknown is the radius.
Oh, that's awesome. I'm so excited. Okay, thank you, Ms. Wall.
All right, so we have a radius of 3.2, so I'm going to go ahead and go back to my calculator. So alpha y equals, and put in 4/3, and make sure to always go over to this side. 4/3 pi times our radius, which was 3.2. So up to this point, we've been able to use this button over here, which is our squared button, but now we're going to have to use our caret, which will allow us to put in any number of exponent. So 3.2 to the third power, and you push enter, and you'll get 137.26. And so let's check to make sure we're correct. 137.26, or to the 10th, we would have 137.3 feet cubed. All right. So if I were to, so again, you're not going to be given a height like in the other volume formulas. The only unknown that you'll have to find is the radius. And so we're going to look at one star example. So they always like to make things a little wordy. So it says a ball shaped like a sphere has a radius of 2.7 centimeters. Which measurement is closest to the volume of the ball in cubic centimeters? So the thing that could be a little tricky about this one is the fact that there's no picture. But because you have big brains, we know that a ball, and it even tells you that it's shaped like a sphere. So we have a ball. I'm just going to draw that two-dimensional object. And I'm going to write in my radius of 2.7 centimeters. And then I'm going to have my formula, substitute, solve. So again, this is a formula you don't have to memorize. It'll be available for you. V equals 4/3 pi times radius. And again, remembering that it is cubed. So when we substitute here, we have 4/3 times pi times 2.7 to the third power. So as we go into our calculator, I'm going to do alpha y equals 4/3 pi times, I already forgot my number, 2.7, again, caret, giving your exponent to the third power. So that leaves us at 82.45, remembering that 5 or more raise the score, 4 or less let it rest. So we will be raising that 4 to a 5. And that leaves us at answer choice D. And that is our quick lesson on spheres.